Today, chapter 3, graphs and functions, and the section is 3.3, graphing linear functions. Let's go straight to this example, and we have here two different linear functions, and we have one function is gx equals 2x plus 1, and another function fx equals 2x. Let's graph and compare these two different functions. And the first thing you have to do here is this kind of table that's going to help you. And we will do this really small. And here this is x, this is fx, and this is gx. Okay, and we will assume some values for x, 0, the first one, then 1, 2, and we will calculate the fx and the gx for each value of x. So if x equals 0, fx equals 2 times 0, 0. And gx 2 times 0, 0 plus 1, 1. If x equals 1, fx equals 2 times 1, 2. And gx is 2 times 1 plus 1, 3. And when x equals 2, fx equals 2 times 2, 4. And gx 2 times 2, 4 plus 1, 5. Now we have here ordered pairs 0, 0 and 0, 1, 1, 2 and 1, 3, 2, 4 and 2, 5. And we will we will graph this on our coordinate system, the x and y axis. Let's do the fx is going to be in blue. So fx is going to be in blue, and gx, we will use the red line. Okay, so let's start with the fx. No, this blue, purple. Fx, let's do this purple. 0 and 0. 1 and 2, so 1 and 2, and 2 and 4, 2 and 4. So this is fx. Let's get the ruler, align the ruler with these 3 points, and then we have okay, the graph of fx, and this is fx. Now gx is going to be red, and gx is 0 and 1, x equals 0 and y equals 1. So here x equals 1 and y equals 3. 1, 2, 3. And x equals 2 and y equals 5. And now we get the ruler and we draw the line, which is the graph, the gx graph. Okay, and this is gx. And well, it's kind of the same thing. We just swap the colors, but it's kind of the same thing as the PowerPoint. And one interesting thing is they are parallel lines, and we will see later why. And this is how we graph and compare two linear functions. Second objective, graphing linear functions by using intercepts. First thing, identifying intercepts. We have a function here as an example, which is y equals 4x minus 8, and the intercept, the y-intercept of this function is going to be where the graph crosses the y-axis. And that means where x equals 0. If you have x equals 0, this is the y-intercept. And this is where y equals 4 times 0 minus 8, y equals negative 8. So 0 and 1, 2, 3, 4, 5, 6, 7, and one more, 8. Negative 8. This is what? Say again, y-intercept. And the x-intercept, where y equals 0, this is the x-intercept. That means 0 equals 4x minus 8. Add 8 on both sides. You have 8 equals 4x divided by 4 on both sides. X equals 8 divided by 4, 2. So the x-intercept is where y equals 0 and x equals, in this function here, in this situation here, x equals 2. This is the x-intercept. And we can draw the function. Let's get the ruler. We can graph the function by using the x and y intercept and drawing a line that crosses the x-intercept and the y-intercept. And this is the function y equals 4x minus 8. Notice that the y-intercept of the graph of gx equal 4x minus 8 on the previous slide is 0 and negative 8. In general, if a linear function is written in the form fx or y equals 4x mx plus b, the y-intercept is 0 and b. And this situation here, b is negative 8, right? Negative 8. All right, more examples. Find the y-intercept. If we have this function as fx equals negative 2.1 x plus 3.6, the y-intercept is 0 and b, and here b is 3.6. This other function here, y equals negative 5x minus 1/3. Y-intercept 0 and b. Okay, and b here is -1/3. To find an x-intercept, as we have seen, you let y equals 0 or f of x equals 0 and solve for x. On the other hand, to find the y-intercept, you let x equals 0 and solve for y. Let's work out this example. Graph 4 equals x minus 3y by finding and plotting its intercepts. So we learned that to find the intercept, the y-intercept, what do? We make x equals 0. So 4 equals 0 minus 3y. Here, let's use multiplication property, divide both sides by -3. So we have -4/3 equals y. Y equals -4/3. So that means the y-intercept is 0, x equals 0, and y equals -4/3. Okay. Find x-intercept now. Now to find x-intercept, what should you do? What's going to be 0? Y is going to be 0. So you plug in y equals 0 in the function, and that means 4 equals x minus 3 times 0. And you're going to see that x equals 4. So we can say that the x-intercept is equal x equals 4 and y equals 0. That's it. It is usually interesting to have at least 3 points to graph the linear function, just to be sure that you didn't make any mistakes. Because you can graph having only 2 points, but it's better to have 3 points just to be sure. So you're going to find another point here by letting y equals 1, making y equals 1. And then we plug in on the function. That means 4 equals x minus 3 times 1. And in this situation here, we add 3 on both sides. Addition property. Right? And 4 plus 3, 7. X. -3 plus 3, 0. So x equals 7. Now you have 3 distinct ordered pairs, and you can draw the points, draw the ordered pairs on your coordinate system. Then use the ruler and make the line connecting all these 3 points, going through all these 3 points. Okay, let's try another example. And now the example is asking to graph the function 2x equals y by finding and plotting its intercepts. So first thing, y-intercept. You make x equals 0. So 2 times 0 equals y. Y equals 2 times 0, 0. And this is a particular situation where x-intercept and y-intercept are the same, or the ordered pair 0 and 0. 0 and 0. Okay? They are the same. They are the origin of the coordinate system. What should we do? Well, now we have y-intercept and x-intercept that are the same points. Now I have to find 2 other different points to be able to graph this function. Hint, notice that anytime the ordered pair 0 and 0 is a point of a graph, then it is an x-intercept and a y-intercept. It is the only point that lies on both axes. And to find other points, we just guess or assume values for x. Let's say x equals 3. Then y is going to be 2 times 3 equals y. Y equals 6. So now we have another order pair, 3 and 6. And we need a third ordered pair. And let's make y. Let's follow the PowerPoint. Let's make y equals 4. Y equals 4. That means 2 times x equals 4. Then x equals, divide both sides by 2, x equals 2. Now we have another order pair, 2 and 4. And then, with this, we have all the 3 order pairs that you need to graph the function. Okay? Go to your coordinate system, x and y, plot the points, plot the order pairs, 0 and 0, 2 and 4, 3 and 6. Draw a line going through all these 3 points. And don't forget, these lines have arrows on both extremities of the line. Why? Because this goes all the way to infinity. So negative infinity, positive infinity. Okay? This is an infinite line. And this is how you graph this function, which is 2x equals y. Graphing vertical and horizontal lines. Now let's go straight to an example. Graph x equals -3. -3, if you go here to the x-axis, is going to be here 1, 2, 3. This is -3. Any value we substitute for y gives an x coordinate of -3. So any value of I, x is going to be always -3. That means that this equation here, we're going to represent as a vertical line. A vertical line. And this vertical line looks like this, because for any value of y, x is going always to be -3. The y-intercept is here. The x-intercept, I mean, is here. X-intercept. And what about the y-intercept? There is no y-intercept. This line is parallel to the y-axis. There's no y-intercept. There's no intersection with the y-axis. And just another remark, this equation, this graph here, is not the graph of a function. Why? Because you're going to have, for one x, you're going to have several, actually infinite number of y values. So it's not a function. Now, another thing, another example. Graph y equals 3. Y equals 3. So now we're going to graph y equals 3. That means y equals 1, 2, 3. This is 3 here. For any x value, y is going to be equals to 3. That means this graph is going to be a horizontal line. This is going to be a horizontal line crossing, going through y equals 3. For any x, y is always going to be equals to 3. X, y-intercept is here. This is y-intercept. And what about x-intercept? There's no x-intercept, right? Because they are parallel. This line here is parallel to the x-axis, and there's no intersection with the x-axis. Okay? So vertical lines, if the equation is x equals c, where c is a real number, this is going to be a vertical line with x-intercept equals to the ordered pair c and 0. And horizontal lines, the graph of the equation y equals c is going to be a horizontal line where the y-intercept is going to be the ordered pair 0 and c.